Okay, right now we're going to look at your paper 2. This is from May of 2013. Okay, and this is time zone 1. That's what that means. So we're going to have May 2013. We're going to look at paper 2. Okay, from that time zone. So I suggest you have this test in front of you before you start looking at this. In fact, you may actually want to try to complete the test by yourself, and then look at this to check your answers, or to better understand how to get the answers once you've completed it. So that's my suggestion. You should have this paper in front of you when you're watching this video. Otherwise, it's not going to be all that useful. So have that paper in front of you, and then let's go through these answers here. All right, so let's get started. I'm going to change my view here to a dual display so I can see more than one page at a time here. And we have this. So I'll look at question 1. I'm going to go ahead and insert a page, I think. Yeah. So let's go back here. Get a page inserted. All right. So we can get some workspace here. All right. So this is a number 1 here. Looks like a chi-square test by the looks of things when I'm glancing over it. So let's take a look here. It looks like a contingency table. So we have fertilizer and yield. So let's take a quick look here. An agricultural cooperative uses 3 brands of fertilizer. Okay, so these are brands, A, B, and C, on 120 different crops. That's what they gave me, this total right here, 120. Crop yields are classified as high, medium, or low. All right, so you don't want to spend a whole lot of time reading, but glance over it, make sure you understand everything that's going on. The agricultural cooperative decides to conduct a chi-square test at a 1% significance level. That's really important that you understand. That's 1%. Typically it's 5%, but now they make it 1%. Not that we really care that much. All right. It says here, state the null hypothesis for this test. All right. So standard null hypothesis is saying these two things are independent: the fertilizer brand A, B, and C, and the crop yield. Okay. So we're going to say fertilizer brand and crop yields are independent. That's it. Independent. That is our null hypothesis, is what we call it, right? That is our null. So that's just part A. It's done. It's an easy 2 marks, okay? Don't leave it on the paper. Put it on your answer document, all right? Write down the number of degrees of freedom. That's very simple, okay? Degrees of freedom is rows minus 1 times columns minus 1, okay? So keep in mind that the totals don't count as a row or as a column. We only look at this part right here. This is the only part that we're concerned about for our contingency table. So it looks like we have 3 rows and 3 columns, so it's going to be 3 minus 1 times 3 minus 1, which is 2 times 2, which is 4. So the degrees of freedom is 4. That's that answer right there, okay? Put that on your answer document. That's an easy mark. So you got 3 marks so far. You get 15 minutes per question if there's 6 questions. So remember, we probably won't spend that much time doing this question based on the speed that we're going through, right? So let's just keep through this. So write down the critical value for this test, all right? The critical value can only be garnered from a critical value table, all right? So let's pull one up here. Okay, I don't even have one here. Okay, so we're looking at a critical value table. They generally look something like this, okay? They can vary a little bit, but it really depends on whether or not the area they're giving you is to the right of the chi-square statistic or to the left. So be careful here. Here in this case, it's to the right. So we're going to look at the area of the right. This is our significance level is what they're telling me, okay? The area shaded is equal to alpha. For chi-squared is equal to chi-squared alpha, right? So this would be a critical value, chi-squared alpha right here. And alpha is your significance level, which would be, in our case, 1%, right? So 1% here then, if this alpha is to the right, this alpha is 1%, so we're looking for 0.01. This one right here, that's one that we're going to use in this particular case. All right, so our degrees of freedom is 4. We know this, right? We can see that. 4, so we just follow this table all the way over to here, and our critical value is 13.2 13.277. That's what I want to get from the critical value table. This is an old test. I think usually on newer tests they will give you this critical value, but because critical value tables don't really appear on new formula charts, although they appeared on the old one. So, like I said, this because it's an old test, they probably would have given you this table, and just pay attention to that. So 13.277 is what we're going to go with for that critical value. All right, so critical value is 13.277. That looks awful. 13.277. It's our critical value, so we call that our chi-square critical value. Okay. All right, so that's that. Easy point. Show that the expected number of median crop yields fertilizer C for the medium yield and fertilizer C is 17. That's the expected number. They want to know what that is. So to do that, it's pretty easy. We just pay attention to the yield and the fertilizer that they want. So the yield they have, this total for the medium yield, we'll take the row total, which is 50. And then we'll keep in mind that we have the fertilizer C that we want. So we're going to look at the total for the fertilizer, which is here, 40. We're going to multiply those together. The row total times the column total, and we'll divide it by the grand total, which is 120 what? That's 120 different crops. So we're going to divide it by 120. So we'll just put this in the calculator. This will be our expected value for that particular piece. You could actually make several of these values and fill in an expected value table if they asked you, but they're not doing that right here. So let's take a look. 50 times 40 divided by 120. So let's go ahead and make a new document here, clear this out. And I'll do control divide. We'll do 50 times 40 divided by 120. And that'll give me 50 over 3. Now if you want that as a decimal, we'll say 50 over 3. You can put a decimal point on the end of it, and it'll give me 16.66. So that's what I'm going to put as my expected value for that, 16.66, but we can say 16.7 to 3 sig figs. All right. They want it to correct to the nearest integer. Careful there. So this would actually be 17. That would be the actual answer for that. So we can ignore that. That's the correct to the nearest integer whole number, right? Okay. So that's done. Use your graphic display calculator to find this data. They want the chi-square value, the stat. So they want the calculated value. They want to get the chi-square statistics. So we have to use the calculator to do this quickly. If you didn't have a calculator, you could do it by hand, but this would take some time. So to do this, we're actually going to use this contingency table. We're going to have to plug it into a matrix, into our calculator. So let's go ahead and do that really quick. I need that. Let's do that. So let's actually go to menu, matrix and vector. We're going to create a matrix, and we need a 3 by 3. So I'm going to create a matrix that is a 3 by 3 matrix to fit the contingency table. So we'll just type in these values from the contingency table we can see, which is 10 and 8 and 12. Now we get 15 minutes to do this, so do it quickly, but don't rush through it and make a mistake. And then we'll finish this, all right? This calculator will tell me the chi-square statistic and a lot of other things, including the p-value, which is the next question, and the degrees of freedom, and do all that. So once you get the matrix, you need to store it into a letter, some sort of variable. So I'll hit Control var right here, and I'll store it into, let's call it B. So I'll hit Enter. So now every time I type B, the calculator thinks B is a matrix, as you can see. So now what I'm going to do is go to Menu, Statistics, Stat Tests, and go to the chi-square 2A test. The observed matrix, I called it B. It's stored already. So I hit OK. And it'll give me everything. So here's the chi-square value that they're asking for, which is 3.86. So we'll go ahead and look at that. So we'll say the chi-square value for E. Oh, there's my pen. Where'd my pen go? All right. So E is 3.86. That is my point. 3.86. That is my chi-square stat, we'll call it. And that is the calculated value, chi-square calculated value. So that's the answer for E part 1 and E part 2, which is the p-value. That's also given to us. It's right here. The p-value is 0.425. Okay, 0.425. So the p-value is 0.425. All right. Yeah. So that's that. So we got this done, this done, this done. State the conclusion of the chi-square test. Well, there's two ways to look at this. All right. The category where we reject the null hypothesis is where our chi-square calculated value is greater than your chi-square crit value, your critical value. Or you could say your p-value is less than your significance level. All right, so let's take a look. Is this true? Do we reject the null or fail to reject? Okay, our chi-square statistic is 3.86, and I'm going to say, is 3.86 greater than my critical value? Which it's not. It's actually less than 13.277. All right, so that means we're going to what? We're not going to reject the null because this condition isn't satisfied. We're going to fail to reject the null hypothesis. Okay. Also, we could say the p-value, which is 0.425. This is also greater than your significance level of 1%, which is 0.01. For this reason, also, we fail to reject the null hypothesis. Okay, so here's the saying: if the p-value, if the p is low, reject HO. But this value is not low; it's bigger than your significance level, so we don't reject HO. We fail to reject the null hypothesis. So the answer for part F is fail to reject HO. They want a reason for the decision. You could put these right here. But we're basically saying that your p-value is greater than significance level. Or you could also say that your chi-square value, right here, your calculated chi-square value, is in fact less than your critical value. Either answer would be acceptable, okay? And they'll give you credit for that. So don't waste a lot of time on this question. Just go on to the next one. All right. So let's do that. Okay, so in this situation, we have looks like a Venn diagram type of question. So it's very common with the with probability and what have you. So we're going to say here is 100 students at an Ivy college were asked whether or not they studied music, chemistry, or economics, and here were the following results. So draw a Venn diagram that represents this information. Very straightforward. Just go for it. First, you should draw a box when you're doing a Venn diagram, a rectangle. This will mean your universal set, okay? So then we'll make, there's 3 classes, so we'll make 3 circles. And I'm trying to be careful, but I don't draw very well. And that should be adequate. Okay, so this will be my music class, this will be my chemistry class, this will be my economics right here. Oops, economics. And there you go. So let's plug in some stuff here. 10 studied all 3. So we got 10 in the middle. Done with that. 15 studied music and chemistry. So 15 belongs in this group here. There should be 15 people in the intersection of music and chemistry. We already have 10 sitting there, so this will be 5. Very important you understand how to do that. 17 studied music and economics. So here's this group right here. Music and economics, we already have 10 sitting in that group, so this will be 7 right here. 12 study chemistry and economics, so 12 study chemistry and economics in this particular bubble right here. So this bubble right here, we call this the chemistry economics intersection. And there should be 12 in there, we already have 10, so there'll be 2. Okay, that's what that is. 11 study music only, so 11 here. 6 study chemistry only, so 6 here. And then that's what we filled out. Now, we can tell we have some stuff missing here, but let's not get carried away by trying to fill stuff in. Let's just keep reading first. So we've drawn this Venn diagram. So that's part A. It says, write down the number of students who study music but not economics. Okay. So in this group, here are the people who study music, and how many of them in this bubble study music and not economics. So let's get a little highlighter here. This is the group of people that study music and no no economics. So that's going to be 16. It's 11 and 5. This is a music bubble that's not in economics. That's pretty straightforward. So that's 16. So that answer, we will do it, is going to be 16. So part B, answer is 16. Done. There are 22 economic students total. So now they're giving me more information. So there's 22 total in this bubble right here. Looks like we already have 10, 17, 19 already there. So there should be 3 people that study only economics, if that's true. And of course, the question is calculate the number of students who study economics only. That's the next question. Wow, big shocker, right? So C part 1, this answer is 3. I can see that because I already know, right? So C part 2. Find the number of students who study none of the 3 subjects. None of these 3 subjects, okay? There's a total of 100 students. So how many do we have in these bubbles here? Let's see. We have 11 and 5, which is 16, and 6, which is 22, 10 more, which is 32, 2 more, which is 34, 7 on top of that, which is 41, and then 3, which is 44. So that should leave a total of 56 that are not actually studying anything. So that answer is 56. Okay, not studying any of these 3 subjects. All right, a student is chosen at random from the 100 above. Okay, find the probability this student studies economics. Well, how many people study economics total? Looks like they told us already though. 22 studied economics total. They already told me that out of the 100. So the chances of getting somebody randomly that studies economics out of that 100 is 22 out of 100. So let's figure out how we get down here. So we can say this is D part 1. That is 22 out of 100, which is 0.22 or 22%. Any of these answers will be acceptable. They'll give you credit for fractions, decimals, or percentages for this, okay? They will. So that one's done. It's the probability that a student randomly chosen out of 100 studies music and chemistry, but not economics. So we can kind of shade that if we wanted to. Music and chemistry, but no eco. So we'll say everybody in music and chemistry that doesn't study economics out of the 100. So it's 11 and 5, which is 16. And we're going to add 6 to that. So that's 22. Interesting. Oh, also, they have to study music and chemistry, so not in economics. So it's 22. That's interesting. Okay. Oh, that's wrong. That's wrong. I don't like that question. Okay. Next question here is the study music and chemistry, but not economics. All right. This is really, you have to be really careful with this. It doesn't say music or chemistry. It means it has music and chemistry. So they study music and chemistry at the same time. So that's this intersection that we're looking at here, right here between music and chemistry. But of this intersection, how many people do not study economics? So they can study music and chemistry, but not eco. So it's actually just this 5 that they're looking for. That's that answer. It's just the 5. And it's kind of confusing because a lot of people are bubbling all of the music and all the chemistry. But that means music or chemistry, not music and chemistry. The words are important. So part 2 here, this is actually just 5 out of 100, which is 0.05 or 5%. And that will be your adequate answer. So we're doing that. Does not study either music or economics. So how many people don't study either music or economics? All right. So no music, no economics. We only have the 6 and the 56. Those are the only people that are not studying music or economics. So we're going to add those together. That gives me 62 out of 100. So that's what that's going to be. That's a pretty straightforward answer. So we can see we're going through this pretty quick. 62 out of 100 or 0.62 or 62%. All of those would be acceptable answers. And the last one, part 4. Does not study music given that the student does not study economics. So this is a conditional probability. The probability of A happening, given that B has already happened, is the intersection of A and B. This is on your formula chart. intersection of A and B over the probability of B happening. So we need basically the probability of getting somebody that doesn't study music and economics. So no music, which is the complement of music, and economics over the probability of getting somebody in economics. All right. So an easier way of looking at it than trying to do this formula is basically we're just focusing on what? The given, and the given is that this person studies economics. So if it's a given, does not study economics, so we have to be really careful with that. Does not study economics, so this is a complement here, E complement. So N complement and E complement right here. So if they do not study economics, that's the only population we're concerned with. So we're going to say everybody outside the eco, which is here, here, and here. Okay, everybody's not an eco. Out of that group, how many of them also do not study what? Music. So out of the green, the people that don't study music are just what? Are just here and here. So here and here. We shouldn't cover that up. Let's not do that. I can't see that. See, we have a different color. Yeah, so 6 and 56. Only those out of this green do not study music. So since we can count the green is 56 and 6, which is 62, and 5, 67, and 11 is 78. This is only going to be the 62, these two right here, out of the 78, if that makes any sense to you. So it'll be 62 out of the 78. Okay, we can do this in the calculator. 62 out of the 78, that will reduce to something. 31 out of 39, which is a fraction, will be, let's do that in a calculator again, 31 divided by 39 decimal is the same thing as 0.794, or 79.4%. So that's how that works, okay? So the intersection of not music and not chemistry, not music and not economics, which is what I was talking about here, is this, okay, right here. This is the intersection of not music, so, and not economics, just these two, divided by, so that was what? That was 56 and 62. Another way of looking at it, if you want, is 62 out of 100, which is the top part. And the probability of getting not economics, which we counted here, was 78. So that's 78 out of 100. And what happens is that these hundreds cancel out, and then you end up getting 62 out of 78, which is what I had for this answer right here, 62 out of 78. So that's how it's kind of done. I suggest you try to avoid using the formula unless you really just don't understand, and just look at the chart. It's a lot easier just to look at the Venn diagram without confusing yourself with the formula chart. So just say, okay, this is the group that what? Does not study economics right here. And then we just want the kids there out of that group that what? Also do not study music. So that's what I would have done. Anyway, it's a pretty straightforward question, and we'll move on. I'll answer to page 4. So this is number 3 here. Okay. This looks like well, we got a table here of values. And probably going to have to use a list and spreadsheet on a calculator to do it. So let's take a look at it. So George leaves a cup of coffee to cool and measures his temperature every minute. His results are shown in the table below. Yeah, you don't say. Write down the decrease in the temperature of the coffee. So, all right, during the first minute was the first one. Okay, so A1. During the first minute, we drop from 94 to 54. So this is negative 40 degrees Celsius. That's the temperature drop. That's the decrease, all right? And part 2. So I don't know. So you have to be careful. Are they going to give you credit for negative or positive? That's another thing you have to consider. We might want to leave these positive for the answers, even though that we're dropping. It's assumed to be decreasing, so it's going to decrease by this. So let's leave it as a positive 40 degrees, because this can get tricky. You don't know exactly what they're looking for, and we'll have to check the answer key. And obviously, you don't get the benefit of doing that on a real test. So let's kind of get a consistency for what they're doing. So I'm going to leave them as positive, and then we'll double check that. So During the second minute, we're going to drop from 54 to 34, so that's obviously a drop of 20 degrees Celsius. And we'll keep going. This is A part 1, A part 2, A part 3. During the third minute, we're going to drop from 34 to 24, so that's 10 degrees, obviously. So these are easy 3 marks that you make right here. Okay, so we do part B. Assuming this pattern to the answers continues, show that K equals 19. All right, so what's happened here is we basically are dropping by half of what we had before. So it starts at 48, but half of 40 is 20. So half of 20 is 10. Half of 10 will be 5. So basically what I'm going to say is that 24 minus 5 is equal to K, and that K is equal to 19, because that's true. Okay, so that's, all we can really do is show it like that. I don't really know how else we could show that pattern. Interesting question, right? So we're going to do part C. Use 7 results in the table. Use the 7 results we have. That's true because we started 0, so we go up to 6. There's 7 results. We know that this one is actually 19 now, right? It says use the 7 results, a draw graph that shows how the temperature of the coffee changes during the first 6 minutes. Use the scale of 2 centimeters to represent 1 minute, and on the horizontal axis, and 1 centimeter to represent 10 degrees on the vertical axis. So we're going to have to use a graph paper, right? So I'm going to go ahead and pull one up here, and we'll do a quick sketch of this mess. All right, so let's do that. Okay, so we're going to look at a graph here. Assuming you have graph paper, right? So if you have graph paper, they want the horizontal axis to be represented with a scale of 2 centimeters. So each one of these we'll call a centimeter, right? So it says 2 centimeters in part C here should be 1 minute. So here is 1 minute, 2 minutes, 3 minutes, 4 minutes, so 3, 5 minutes, 6 minutes, 7, 8, 9. Okay, and don't spend a whole lot of time drawing a graph. Don't spend more than about 2 minutes doing this, okay? It says on the vertical it wants 1 centimeter to be temperature, right? So 10 degrees in Celsius, right? So 20, 30, 40. Okay, let's keep going. 50, 60. It's got to about 100. That's what the scale kind of does. 80, 90, 100. So this is degrees Celsius, and this is your time. And you should label your graph in minutes. And that's it. All right. So we're going to plot this point 0.94. That's about right here. Don't really spend a lot of time on it. They're not going to grade it very accurately. So 1 and 54, just kind of guess about where it is. 2 and 34, and really just going to go through this kind of quickly, and don't be exact necessarily. 324 should be roughly accurate. 419, which is about right there, and then 5 and 16.5, which is about right here, and then 6 and 15.25, which is about right here. And you can see you start to level off a little bit. Okay, so there we go. We plotted those points, okay? All right, so we draw a graph. It shows how the temperature is changing. Looks like it's leveling off right here, so it's going to have like more likely an asymptote, okay? It says on this next part, let's go back to this other part here. Let's actually open this up. I want this one. Yes, I do. Okay. Let's go back to this one. Let's do my dual view here. And keep going. All right, so going back to this question here, it says the function that models the change in temperature of the coffee is given by this, okay? Use the values t equals 0 and y equals 94 to form an equation in P and Q. So they're basically giving you a value for t and a value for y, and they want you to plug them in for y and for t right here, okay? So I'm going to go ahead and copy this equation really quick here, and I'm going to say this is 2 negative t. I don't know why it's showing up in red there. And then plus q. So I'm going to replace this y and this t. So y is going to be 94. This is equal to p to the power of 2 to the power of negative 0 plus q. Negative 0 is the same thing as 0. Anything to the power of 0 is 1. So that's really going to become 1, folks, right here. This is 1. So really what I have here is 94 is equal to p plus q. That's really an equation that I have, okay? So that's the first equation. That's the one. That's part 1. Use the values of t equals 1, y equals 54 to form a second equation. So they want a second equation. So I'm going to say, okay, y is 54 in this case. P is just 2 to the power of negative 1, right, plus q. Yeah. So here's the second equation. Another way you can write this is 54 plus p over 2. I'm sorry, equals p over 2, equals p over 2 plus q. So that's your second equation right here. So that's that one. Okay, now it says solve this equations you found in p and q. So you have a system here. You have one equation and have another equation. And when you figure out the values of p and q, your calculator will do this very quickly. So since you get to use a calculator, go ahead and do that. So open up the calculator. We go to menu, algebra, and go to solve system of equations. That'll be the second option on yours. And system of linear equations. So I say I have 2 equations, and the variables, instead of x and y, we're going to change it to p and q because that's what they are for this problem. And that'll allow us to use exact variables. So you can, let's change it to whatever they have. So p and q. So I'm going to say p, comma, q, and hit OK. Now I'm going to type in the equations that they gave me. It's going to move us over here, so we can see this 94 equals p plus q. So I'll type that in. The first one, 94 equals p plus q. All right, p plus q, really quick. And then the second one is going to be, looks like 54 equals p over 2, so I control divide, p divided by 2, and then move it out here and say plus q, really simple. Hit enter, and it gives you the values for p and q. P and q are 80 and 14 respectively, so p equals 80 and q equals 14. So those are the values of p and q, so that's the answer for part E. Done with that. Moving on. The graph of this function has a horizontal asymptote. You don't say. Write down the equation of this asymptote. Okay, let's go back and look at that one. All right. Actually, as it turns out, we can find that because if t gets sufficiently large, if you actually look at this equation that they've given you, if t gets really big, then we're going to have a number in front of under p that's getting really, really big. So this whole thing will get really, really small. In fact, this will approach 0, right? So if I have this equation here, y is equal to p to the power of negative t plus q, and I make this sufficiently large, this value of t, this is going to approach 0. So what's going to happen is that y will equal whatever q is, okay? Now, since we know q is 14, we can then say that the asymptote is y equals 14, okay? If you are not sure about this, you could actually graph plugging in this. You could plug in 80 back into p and 14 into here, graph it, and then just trace to the right, okay? Just trace the graph as far right as you can see, and basically what you're going to see is that the value is going to converge on y equals 14 if you don't know how asymptotes work. So that's the answer for that one, and that is part F. This whole thing is done, so let's move on to the next question. All right, oops. And we'll go, oh, this continues this question. It's not even done yet. All right, great. George decides to model the change in temperature of the coffee with a linear function using a correlation of linear regression. That's really not a good idea because this is not a linear function. Okay, he wants to model it as a linear function, but it's not one. It's an exponential function. But let's see what happens. Use the 7 results in the table. Okay, let's see. What 7 results do we have here? Yeah, we have 7 results in the table to write down the correlation coefficient of a linear function. Okay, so we have to do a linear correlation and make the coefficient and then actually give the equation of a regression line. So this is two things we're going to have to do here. So we're going to have to use a calculator. This is a foolish thing to do, only because this is not a linear function anyway. But let's just humor them, okay? So let's go along with what they're saying. So I'm actually going to make a new document, actually. So I'm going to make a new document. I'm not going to save this, so I'm going to go add a list and spreadsheet, and we're going to have to put in the x and y values from the table. So I'm actually going to peek back at the table, since I can't see it, and I'm going to move this calculator up here. Oops. And let's take a look at the calculator. So we're going to use these values right here on the table and put them in here so you can see them. All right, so I say x, and we'll have y. That's what I always call it, x and y every time. And then we'll put these numbers in. So this is going to be 0, 1, 2, 3, 4, 5, 6. So this is the part that's taking time, right? And then you have to go back up to 0 and then type in the y values, starting off with 94. Looks like 54, 34, 24, and 19, which is the k value, 16.5, and 15.25. Just be careful you don't make a mistake when you're typing in stuff, but don't spend a lot of time on it. Okay, and I'm just going to go over to the next column at the very top. That's the way I like to do it. And since I know how to do a linear regression, I'm going to go to Menu, Statistics, Stat Calculations, Linear Regression, right here, mx plus b. Okay, the x list, I called it x, of course. The y list, I always call it y. There it is. We're going to save this function into f1. That's really important. So I hit OK. Okay, so it gives me the equation of the linear regression. The slope is right here, and the y-intercept is right here. But if I look, just hit down once, it'll give me the Pearson's product moment correlation coefficient, which is negative 0.877. We'll call it negative 0.878. And that was actually one of the questions, as it turns out. It is right here. It says, what is this correlation coefficient? So that G part 1 is negative 0.878. That is your correlation coefficient, okay? So that's your R value, we call it. All right, so the next one is part 2 for G, the equation of the regression line, okay? We have it right here, technically the slope and the intercept, so you can say it's negative 11.6 or negative 11.7 and 71.6. So we could do that. So we can say y equals negative 11.7 x plus, and that one was, of course, oops, it was, of course, 71.6, we called it, 71.6. This is technically an accurate equation of a regression line, y on t. So instead of x, we'll call it what? We'll call it t, because remember, you're not using x variable, you're using t. So go ahead and make sure that's a t right there, and then this will be correct, okay? Use the equation of the regression line to estimate the temperature of the coffee at t equals 3. Your calculator is happy to do this for you if you know how to use that. So we're actually going to graph this function that we have here, but I've already stored it, so it's okay. Hey, Control Doc, make a new page, add graph. Okay, and you can see the first thing says F2. We stored our function at F1, if you recall. So if I hit up on this calculator, it'll actually give me the function that's already stored. I hit enter, and it's graph for you. And they want where t equals 3, so I get a table, Control T. And right here at t equals 3, it is 36.7. That's the answer that they're going to give us for our estimate. So H right here is 37. What did I say? It was 37.7. 36.7. 36.7. That's what we have for that one from the table. All right, so find the percent error. So there's a difference here between what we actually have at t equals 3 and what they gave us in the table. And what they gave us in the table was when t is 3, the answer is 24. So we're going to compare those, the estimate that we had and what we actually got. So we're comparing this versus 24. So this is the what we call the approximate value from your formula chart right here. And we have an exact value, which is 24. Okay, so, oops, let's then use the formula they have. So the formula for this, they'll say this is your percent error, we'll call it, is your approximate value minus your exact value, absolute value divided by your exact value times 100. So what I really have is 36.7 minus 24 over 24 times 100. So dump it in a calculator, get an answer. You're done with this question finally. So I'm just going to hit Control Doc, make a new calculator page, and then I'll say 36.7 minus 24. Divide that answer by 24. Multiply it by 100. And it is a, wow, it's way off, right? It's 52.9. Okay, so we're going to say that percent error is 52.9%. This doesn't shock me really because this is a terrible idea to use a linear regression for this because it's not a linear function, right? You can't model this with a linear function because it's not a linear function. It is actually a exponential function. So this is a huge percent error, and that was expected because this is a awful idea. George doing this right here is just not a good idea, but you know, that's what the question is telling us to do, so we'll play along, right? So that's the answer for that one. All right, so let's go on to the next question. All right, so we have this one here. This looks like a yeah, we have a derivative here. So this is a derivative question. These are very common on paper 2 questions. So they're also very interesting. So they get a graph for us. They can be challenging if you don't know how this works, but if you do, it's fine, right? So I'm going to go ahead and do some work on here, on this side here. Actually, I'm just going to insert a page. What is what I'm going to do here? Let's see if I can do that. Yeah, that's what I thought was going to happen. Let's put a page in there. There we go. So they're going to give me this function here, f of x, and there's the function here, and it says calculate f of 1. That's very simple. We're just going to plug in 1 for the x right here. So I'm going to go ahead and write a, I'm going to say f of x. I'm just going to copy it really quick because I like to see what I'm doing, plus x minus 6, right? Now they want f of 1. So they're going to plug in 1 in for x. So everything you see x here is a 1. So 14 over 1 is 14, plus 1 minus 6, that's 15 minus 6, which is 9. So that's the answer for that one. Very straightforward. Okay, find f prime. So we're going to take the derivative of this. Now I like to usually I don't like writing functions with fractions, so I'm going to change that to make it easier for me. 14 over x is the same thing as 14 times x to the power of negative 1 because the power of x here is 1. You should know that from algebra 1, so this is plus x and then minus 6. So the derivative is f prime, and we'll say negative 1 times 14, the power times the coefficient, is negative 14. We will subtract 1 from the power, which is negative 2, x to the power of 1, so this is just plus 1, and then the x is gone. The derivative of a constant is nothing, so basically you have this is your answer. Another way of writing this, of course, would be f prime is equal to negative 14 over x squared plus 1. This is also accurate to say this, okay? So either one technically is correct. They should give you credit for putting negative 2 there, but, you know, whatever you feel more comfortable with. So that's the answer for that one. Use your answer in part B, your derivative, to show that the x-coordinate of the local minimum of the graph of f is 3.7, correct to 2 significant figures. This is a derivative, and the derivative is basically a gradient of a tangent line. That's what this means. This whole thing is a gradient of a tangent line. They want to show that there's a local minimum. Now, if you have a graph and you have a bunch of tangent lines on it, like at different points, that's a tangent line, this is a tangent line, this will have a negative slope and a positive slope. But at a local minimum, the slope will be 0. Because this derivative is the slope of a tangent line, to find this minimum point here, we will set this derivative equal to the slope, which is 0. So what I'm going to say then is that this derivative here, which is negative 14 over x squared plus 1, is equal to, in fact, 0. So when I do that, I can then say that negative 14 over x squared is equal to negative 1, because I subtract 1 from both sides. That means negative 14 is equal to negative x squared when I multiply both sides by what? By x squared, you should see. And then the negatives will cancel really. So I'm saying x squared is equal to 14. So x is the square root of 14. And this, of course, if you plug that into your trusty dusty calculator, is control square root 14 will be about, that's not very useful, is it? Control square root of 14. Let's put a decimal on it. I have this mode set up here. It is 3.74. Okay. So 3.7 to two significant figures. That's what they wanted me to show. That was the whole idea. So that's what I'd done. Okay. And I've shown it, basically. Okay, find the range of f. This is pretty straightforward. The range is a set of y values. So they want the maximum y value versus the absolute minimum y value, where the minimum point is right around here. They want the minimum point. Okay. As it turns out, though, I know this minimum point is going to occur at about 3.7 because that's I just proved that. That's what I found. That's where the local minimum is occurring. Okay. So if that's the case, I can easily find the maximum because that's going to occur since this window is between 1 and 7. This y value is, x value is 7 and this x value is 1. To figure out f of 1, I already found it. Technically, I already used the answer. I told you that answer already, and that f of 1 value, as you recall, is 9. So f of 1 is actually 9. This maximum is 9 right here. But the minimum value I have to find still. So what I'm going to do, actually, is I'm going to plug in the x value for the minimum, 3.7, back into this original equation. Okay? So I want to do 14 divided by 3.7 plus 3.7 minus 6. And that will tell me this minimum point, right? So let's do the calculator to do that. So we'll say control divide, 14 divided by 3.7. Okay, and it says plus 3.7, plugging in for the x, and then minus 6. This will give you 1.48. Okay, 1.48, that's our minimum point, 1.48. Okay, so if I want the range can be written for this question. Let's move it down here. Part D, the range can be written, let's change the color up to like purple or something, is that y will be greater than 1.48, but less than 9. And it's important that you write it only like this, okay? And that's the range. And we could also say equal to, because these are inclusive. That's a point, and that point is a closed circle. So this is your answer for part D. Nothing else really is acceptable, and it's an easy question to get wrong if you don't understand how to calculate a range, or that you don't understand that B is in fact not a minimum point. So be very careful. Okay, it's not asking you for a domain. A lot of people will put 1 to 7, but that's foolish because that's a domain, not a range. So be very careful. All right. So points A and B lie on the graph. The coordinates of A and B are 1 and 7. Yes, I already told you that, 1 and 7. That's the coordinates of A and B for the x values. Write down the y coordinate of B. That's really simple. They want to know what this coordinate is. What's the y coordinate right here? We're going to plug 7 back into these what? X values. Very simple. All right. 14 divided by 7 is 2. 2 plus 7 is 9, and 9 minus 6 is 3. So this is 3. You can do this in your head. So that one is really simple. E is 3. That's lame. Okay. Now, we have the y coordinate B. That's done. Find the gradient of the straight line passing through A and B. So they want to know if there's a line passing through A and B, what is the gradient of this line? Okay. Well, this is really easy because I have a coordinate here that I know. The x value is 1 and the y value is 9. And here the x value here is 7 and the y value I know is 3. So to find a gradient, it's a slope, right? So it's some algebra 1 problem here. We know that the slope is equal to y2 minus y1 over x2 minus x1. This is all grade school stuff. So this is basically 3 minus 9 over 7 minus 1. That's a negative 6 over 6. So this is negative 1. That's the gradient, folks. That's the answer. Okay, really simple. The midpoint on the line segment AB, write down the coordinates of M. So M is the midpoint. They want it right here somewhere in the midpoint. I don't know where it is. Let's say like that. That's M. They want to find the coordinates. Another formula for that from geometry. So let's actually change my color up. This is part G. What I'm going to do is add these x values. Okay, so the midpoint formula, we'll call it, is we'll add the x values, x1 plus x2, and divide by 2. And add the y values, y1 plus y2, and divide by 2. So let's add this right here. This is going to be 1 plus 7 divided by 2, and it's going to be 9 plus 3 divided by 2. 1 plus 7 is 8 divided by 2. This will be 4. And 9 plus 3 is 12 divided by 2, which is 6. So this answer is, that's the midpoint, 4, 6. So it's right here, 4, comma 6. That's the midpoint. That's the answer for this one. This is really simple. So just, you're done, right? Go through. Or are you? Is more to this question? Yeah, the question continues. It always does, right? So let's see what this is. The question continues, and let's see where it continues to. Right here. L is the tangent to the graph of the function y equals f of x at the point on the graph with the same x coordinate as m. Okay, so this is kind of what this looks like. If we go back to the graph really quick, right here, the same x coordinate as m. So basically there's a tangent right here wherever m is, and it's hitting the graph somewhere. I don't know what it looks like exactly, but it's kind of like that. And what are they asking me here? Let's see. They want to know the gradient of L. Okay, so if it's a tangent line, its slope can actually be found using the derivative. But they're telling me that it's at the point of the graph that has the same coordinate as m, so we know that the x value there is 4. So remember, if you get the previous question wrong, you're going to get this one wrong. But we know x is 4. If we plug this into the derivative, we can find the gradient. So the gradient is really f prime of 4. That's how you're going to find it. All right, so that's really simple. Let's recall that the gradient here, the derivative of this function that we found, is right here. This is the derivative. So we're just going to plug 4 into this x. So it's negative 14 over 4 squared plus 1. So let's do that. Let's see. Negative 14 over 4 squared, and then plus 1. So this is negative 14 over 16 plus 1, and that is equal to negative 7 over 8 plus 1, which is equal to negative 7 over 8 plus 8 over 8, which is equal to 1 over 8. That's the gradient right there. Okay, very simple if you can convert fractions. 8 over 8 is the same thing as 1. That's how this is so easy. Find the equation of L. Give your answer in the form of y equals mx plus c. All right, so this is really simple too. We just need a couple things. We know that it goes through the coordinates m, and we know the coordinates of m are 4 and 6, so that's helpful. That gives me an x value and a y value. I also know that the new gradient, my slope, is this. So if I write the equation y equals mx plus b is what we usually call it, instead of c, which is no different. I'm going to take the x value right here and plug it into x. This is going to be a 4. I'm going to take the y value that I know, which is 6, plug it into y, and then the m, of course, is 1 over 8. This is going to go into this point. The only thing I don't know is b, so I'll find it. All right. So I say, okay, 6 is equal to 1 over 8 times 4 plus b. 4 times 1 over 8 is 4 times 1, which is 4, divided by 8, which is a half. So 6 is equal to 1 half plus b. So b is actually equal to 6 minus a half, right? Which is the same thing as 12 halves minus 1 half, which is 11 halves. That's what b is equal to. So the final equation then is, we know mx plus b, and all I need to figure out is m and b. I know that m is 1 over 8, and I found out b is in fact 11 halves. So this is your answer. This is the equation in this form. So you're done with this. So finally we're done with this question, and we'll move on to the next one. Alrighty, number 5. This is the final question on this test, which I'm really relieved, right? I'm sure you are too. This is this looks like a rectangular, prism thingy here. This is a triangular thing. So we're going to actually figure this out. A greenhouse, given by all these vertices here, is constructed on a rectangular concrete base, as I can see, ABCD. So ABCD, yeah, looks pretty rectangular and concrete, sure, and is made of glass. Okay, fine. Its shape is a right prism, okay, with a cross-section of ABQ. So ABQ, the cross-section is a triangle, as you can see, an isosceles triangle, it says. The length of BC is 50, all right, so from B to C, they're telling you this is 50, that's given, and the length of AB is 10, so A to B is 10, they give you that also, and then the angle QBA is 35. Fine, so they label all that stuff that I just told you, which is really nice of them. All right. Write down the size of the angle AQB. So they want to know from A to Q to B. All right, they want to figure out what this angle is. That's what they're asking for. Well, this is really easy though, because if this is an isosceles triangle, as they're saying, that means these sides are equal. They're congruent. That's why they put these little lines here. That means they're the same, which means these angles are also the same. That's a 35-degree angle. There's 180 degrees in a triangle, so 35 and 35 make 70. So that means this angle has to be 110. That's the answer for part A. This is common sense. Okay, so that's your answer for that one. Really simple. Calculate the length of AQ. All right, so they want to know AQ, but that's the same thing as the length of QB. All right, now there's a couple ways you could do this, but what I'm actually going to do is use the law of sines. Okay, law of sines, and law of sines can be used if you have an angle anywhere with an opposite side anywhere. Okay, so as it turns out, I have an angle, which I just found, which is 110, and its opposite side is 10. So the law of sines can be tried. The law of sines looks like this. It's the sine of A over little a equals the sine of B over little b, which is the sine of C over little c. You can turn all these fractions upside down and it would still be correct. So, it wants to know the length. So I'm actually going to turn these upside down. The length, they want to know this length here, which is AQ. They want to know this length here. So that length, I'll call it AQ, which is the one of these right here. We'll call it, it's actually a little b is what this is, over the sine of its opposite angle, which is 35, sine of 35, is in fact equal to 10 over the sine of its opposite angle, which is 110. So now AQ can be solved. It's equal to 10 times sine of 35 over sine of 110. So some of your calculators in degrees, you're already set to do this. So let's make sure though, because I'm never sure. I'm going to check that real fast. You should check this very carefully. I'm going to go to Doc. I'm going to go to Settings. I'm going to go to Document Settings. My calculator is not in degrees. It's in radians. So I'll have a rad time if I don't change it. So I have to change it to degrees. I'm going to make it the default. I'm going to go from there. Okay. So be careful that you are not in radians because your answers will be wrong, and that would be sad. Okay. So we're going to type this in. 10 times sine of 35. So Control Divide. 10 times sine of 35, come on, sine 35, divided by the sine of 110, right? So that's really fantastic. It's doing that. Let's copy that. I got to change my settings here. Let's put a decimal in here somewhere, like there. So it's going to be 6.10 or 6.10. So 6.10, that's what AQ is. That's what I'm going to say it is. So that's what this is. Let me erase this part. And then put that. So 6.1. All right, 6.10 meters is what that is. So that is the length of AQ. That's part B. Calculate the length of AC. AC is what? What is AC? This is weird. This is a diagonal from A all the way to C here. They want all of this. This is actually a right triangle, though, when you look at it. Okay, it makes a right triangle. So since this is a right angle, this is 50 and this is 10. So actually I have two sides of a triangle. To find the diagonal, I use the Pythagorean theorem. This is really a simple problem if you know what to look for. So it says calculate that. So C, we're going to say that A squared plus B squared equals C squared, ladies and germs. So we're going to say 10 squared plus 50 squared is equal to our unknown AC squared. So let's figure out what those are. I don't know. 10 squared is 100, but 50 squared, I'm not sure. What is that? It's, yeah, so that, 2,500. So we're going to say this is basically 2,600 when I add the extra 100 to it is equal to AC squared. So take the square root of both sides. So AC is square root of 2,600, which apparently is, let's have a look, square root of 2,600. Of course, remember I have to put a decimal in mine because of the default setting. It's going to be, we'll call it 51. That's really what it is. Okay, so 51. It's about 51 meters right there. That's AC. Show that the length of CQ is 50.37 millimeters. CQ, okay. So this is different. They want me to show this one, this length here, okay, is 50.37 millimeters, correct, for sig figs. Now, what I know now is not much. I have to prove this, right? But I actually have a triangle here, if you can see this. And this is another right triangle. So I know this length, and I actually know that this length is the same as this one because they are congruent, as you can see. So this is 6.1, I'm going to say. So basically, if you get this question, the previous question wrong, 6.1, you're going to get this wrong. But this is another Pythagorean theorem. It's 6.1 squared from this side squared is equal to this side squared. It's another right triangle. So Pythagorean theorem is popular in this question. And they just want me to show that this is the correct answer. So they already give me the answer. So I'm going to say then, okay, a squared plus b squared equals c squared. I like to show my formulas so that the moderator can see them, or the grader. I'm going to say, okay, this is about 6.1 squared plus 50 squared is equal to what I call, what are they asking for? CQ, we'll call it CQ squared. All right, that's what they're asking me for. Okay, so let's figure out what 6.1 squared is. I'm not even sure. 6.1 all squared is 37.21. Okay, we're going to add that to 2500 because that's 50 squared, we already know. And that's that. So it's 2537.21. So 2537.21 is this plus this. We'll take the square root of that, and that'll equal CQ. And we'll say okay. So we'll take the square root of this. Controlled negative sign will give you the previous answer. I hit enter. It's going to be 50.37. 50.37 as proven. And that's what they told me it was going to be. It's kind of, obvious. So we already knew that, right? So great, we showed it. We have to show this work. That's what they're looking for. Alrighty. Find the sides of the angle AQC. Now I'm getting where I can't see too much, but they want, I'm going to have to erase some of this because I can't see, right? So let's see what I have here. There's a problem when you write too much stuff on here. But they want to know the angle AQC, and I can see what it is here. Alright, so they're looking for from A to Q to C, they want this particular angle, which is interesting, okay? Now, I already know the length of this diagonal. I already found it, which is the from A to C, right? The length of AC was part C. We told it was 51. So I know this length is 51. I also know this diagonal I just found, they're telling me from Q to C is 50.37. So they're giving me stuff that I'm going to need for this triangle here, because this is another triangle, but it's not a right triangle, it's something else. So this is 51, this side length, and we know this side length, right? We also know this side length from A to Q is in fact 6.1. So basically I know all the sides of a triangle. So what they're setting me up for, since I don't know any of the angles, is using the law of cosines. This is a way of forcing me to do that, to show that I know how. So this is find the sides of the angle AQC. They want to know this angle, right? So that's how I'm going to do that. Now the sides of the angle is pretty easy. The law of cosines, we're going to say this, law of cosines looks like this. It's a squared is equal to b squared plus c squared minus 2bc times the cosine of a, right? As it turns out though, if you're solving for the angle, you can rearrange this formula, and then the angle A would be the cosine inverse of a squared minus b squared minus c squared over negative 2bc. So this is kind of the formula we're going to use. It's just a rearrange of this one. Okay, but let's be really clear about what little a, little b, and little c are. Okay, the way I've set this up, if this is my angle A, then here the side opposite that, which is 51, this is my little a. Okay, so we're going to say little a is 51, and little b, which is the side of, we can call this a, we'll call this b, we'll call this c. So the side little b will be 50.37. And little c will be the only other side we don't have, which is 6.1. I'm going to define all of them so you know what I'm doing. And I'm just going to plug them in this equation and solve for the angle, and that's all I'm going to do. Okay, there's really nothing to it. So let's set it up really quick. A is equal to the cosine inverse of 51 squared minus 50.37 squared minus 6.1 squared all divided by negative 2 times 50.37 times 6.1. Tedious work, but not that hard, right? So let's put this in the trusty dusty calculator. I'm going to move over here so I can see. I'm going to do this really quick. So the first thing I'm going to do is cosine inverse. All right, cosine inverse, and then I hit control divide, make a little fraction, and then always parentheses when you're squaring stuff, folks. Even if you don't, you can easily make a mistake. If you don't parentheses a negative number, it'll give you the wrong answer. So parentheses always when you're squaring or raising to any power. So put that in parentheses, we'll square that, we'll subtract parentheses 50.37 squared minus parentheses 6.1 squared. Divide this by parentheses negative 2, close parentheses, times parentheses 50.37, close that, times parentheses 6.1, close that, and this will be enter. Your answer is 92.48 or 92.5 degrees. 92.5 degrees. That is the angle, remember the angle AQC. So we're going to say AQC is this. That's my angle, 92.5 degrees. So that's the answer for that one. And now it says calculate the total area of the glass needed to construct the 2 rectangular faces of the greenhouse. Okay, so there are 2 rectangular faces and a third, which is a base. The base is not a face, it's considered the base, right? So they call that different. So they want this rectangle, and then of course this one back over here. They want these 2, and they're the same. So we know the length here is 6.1 because it's the same as this one, and the width is, well, the width is 6.1 and the length is 50. So the area of a rectangle, it's length times width. So there's 2 rectangles like that. So the total area of the 2 rectangular faces for part F part 1 right here is basically area is given by 2 times 50 times 6.1. It's a very easy question, really. So we're going to say 50 times 6.1 times 2. And that will be the total area, which is exactly 610. Nice, clean number. That's in square meters. So that's the answer for part F, F part 1. And now they want the 2 triangular faces of the greenhouse. They're identical. This triangular face is the same as this one. We just have to find the area of a triangle. It's a little trickier, but there's a formula that's pretty well known. It says the area of a triangle is 1/2 AB sine of C. So basically, how this works is if I have an angle of some sort, okay, we'll call it angle C, then the side here will be A and the side here will be B. So if you have an angle and 2 sides that are adjacent to it, then you can easily find the area of any triangle using this formula. Okay, these are just 2 sides that are on either side of this angle. It doesn't matter what these letters are called. So just find an angle, 2 sides around it, and then you have an area. That's how it always works. It's the same. So, do I have an angle? Yes, I do, 35. Do I have 2 sides? Yeah, this one here is 6.1, and this here is 10. So, that's what we're going to say. We're going to say 1/2, and we're going to have 10 times 6.1 times the sine of that 35-degree angle. And this will give me the area of that triangle, and since there's 2 of them, I'm going to multiply the answer by 2 because they want the 2 triangular faces, right? So let's go and do that. So this is going to be in a calculator again. This is going to be 0.5, which is half, times 10 times 6.1 times the sine of 35 degrees. And this answer will be 17.49, or we'll say 17.5. Okay, that's for one of the triangles, right? And then we're going to have to multiply this by what? By 2 to get both triangles. So when I multiply that by 2, let's do it real quick, times 2, it's going to be about 35. Okay, so let's say 35 square meters. That's the answer for that one. That's part 2. Okay, and we're almost done. The cost of 1 square meter glass used to construct the greenhouse is $4.80. Calculate the cost of glass to make the greenhouse. Give your answer the correct nearest 100 US dollars. Okay. Now, that's 1 square meter of glass to construct the greenhouse. If the whole thing is made out of glass, which is kind of what I'm getting here, then we need the entire surface area, right, to make the whole thing. So this is a surface area question. So there's a couple things we have to consider. So I'm going to erase some things here, right? Since I can't see this anymore. Let's erase all this so I can see, because it's really covered in stuff. I need the area of both the triangles, right? Fortunately, that's why they made us find this, because we know that's 35. They made me do that already. Now we need the area of the two faces right here, here and here. They also made me do that. So there's a reason they're making us calculate these things, because we're going to use them again. This one we have, this one we have. So we have both the rectangular faces and both the triangular faces. Well, the only thing I don't know. Okay, that brings us down to G. All right, so G says that we have, um, it tells us the cost of 1 meter of glass used to construct the greenhouse is $4.80. Calculate the cost of glass to make the greenhouse. Give your answer correct to the nearest 100 US dollars. Okay, so basically they told us in the question that we have a concrete base right here. So this whole thing is concrete, this base. So the left part is glass, or the two uh, triangles ends and then the two rectangle faces. So we already have the areas for those, though. They made us find that. So when they're telling us the cost per square foot, we need to find a surface area of everything except the base, okay? But we have these areas already. We're recycling the answers we already just found. So the area of the two triangular faces are 610, and the area of the two triangular end pieces are a total of 35. So since we have that area, we can just say, okay, add those, 610 plus 35, and then multiply by the costs per square foot, which is 480. Oops, 480, and then we will multiply. Sorry, they will round that to the nearest $100. So let's just go into that really quick. Really easy question. All right, so I have 610 plus 35, which is that, and we'll multiply that by the cost. So 645 square feet of glass that we need. So we'll multiply by the cost per glass per square foot, which is 480. That is that. 3,096. So the nearest, so we'll say this is 3,096 US dollars, and what the nearest $100. So we'll say this is $3,100, which is what they're actually asking me for the answer. Okay, so that's that. And thank you for watching this, and I hope you found that useful. All right, thank you.